Hello and welcome. My topic this time is about application of logarithms or solving word problems involving logarithms. Here's our objective for this lesson. Analyze and solve word problems involving logarithms. Problem number 1. A park has a population of 200 eagles in the year 2019. Conservationists are concerned because the eagle population is decreasing at the rate of 10% per year. If the population continues to decrease at this rate, how long will it take until the population is only 20 eagles? Before we start solving this, let us recall the formula A is equal to P times 1 minus R raised to P. We're going to use the same formula. Now, let us identify the given. So, 200 is the starting number of eagles. So, we have to replace P here with 200. Next, the population is decreasing at the rate of 10%. So, 10% is the rate. This will be 1 minus 10% is the same as 0.1 and then raised to t. Do we have time here? So there's none. How long will it take? How long will it take is referring to time, which is we do not know. So this is time, that's why t here remain t. T is missing or time is missing. So let me write t here as is. T is missing, so simply copy T. Now, what about A? So I think A is given. Yes, it's given here because it says here, how long will it take until the population is only 20 eagles? So this is the expected number of eagles after T years. So we have to replace A here with 20. Looking at this equation, our missing is time. And take note that if the missing is time, this is where we can apply logarithm. That's why this kind of problem is about logarithm. It's not just exponential equation, but logarithm. But still, we're going to apply exponential equation because exponential equation and logarithm are inverse of each other. They help each other for us to solve a particular problem. Continuing this, let's divide both sides by 200. So we can cancel 200 here and then 20 divided by 200 equals 1 minus 0.1 is 0.9. So 0.9 and then raised to time, copy T. Now 20 over 200 is 2 over 20, reduce the lowest term, it's 1/10. Then let's make it decimal. It's 0.1 equals 0.9 raised to T. So looking at this, it looks like exponential equation, but our missing here is t. So it's quite difficult to apply the techniques on finding the value of t or exponent here since it's in decimal. This is where we can apply logarithm. So let's change this to logarithm. So this will be logarithm of 0.1 to base 9. So your 0.9 here should be the base. So logarithm of 0.1 to base 9 is equal to t. We changed to logarithm or to logarithmic equation because it's easy to key in the keys in the calculator. Unlike this one, unlike if in exponential form, it's difficult for us to do this in calculator. Now, with the given logarithm key in the calculator, we can press now the value of t. So, just press logarithm and then 0.1 or 0.9 and then 0.1. If your calculator is scientific or high-tech, then you will see you will see in your calculator key like this. So look for this. And then here you have to put 0.9 and here you have to put 0.1. Then simply click equal sign and you will see the result, which is 21.85 something. So let me just write 0.85 and then round this off to whole number, 22. How long will it take? 22 years. So estimatedly or approximately, there will only be 20 eagles after 22 years. Now, there is another solution. Not all calculators have this symbol. Instead, we can use ln. So from here again, from this exponential function, we can change this to this format. ln 0.1, I'm sorry, 0.1 yon. That's 0.1. Let me change this to 0.1. So ln 0.1, simply copy this part and then put ln before 0.1 equals, this one will become 0.9 raised to t will become t. So put t before ln. So t ln and then copy 0.9. So I hope you can follow. Now our goal is to find t. That's why divide both sides by ln 0.9. So ln 0.9, then ln 0.9 here also. So we can cancel ln 0.9 here on the right. Kasi ln 0.9 divided by ln 0.9 is equal to 1. And then t will remain. Now, you have to use your calculator again. Press ln 0.1 equal sign and then divide by ln 0.9. So expect that your answer is also the same as this, 21.85 and other decimal places. So it's the same, that the answer is 21.85 or estimatedly 22. So the same. Whether you will use logarithm, this formula or equation, or this formula, ln. You can use any method or any formula because you will get the same answer. So it's up to your calculator. If you can't see this symbol in your calculator, use this method because you can see ln in your calculator. In calculator, which is the basic one, so sorry, you cannot see logarithm and even ln. That's why it's advisable for you to use scientific calculator. Let's solve problem number 2. If Mr. Wong invested 2,000 in a bank at an interest rate of 8% compounded annually, how many years will it take for the money to double, assuming that there will be no withdrawals or deposits to be made? So let us recall the formula again. A is equal to P times 1. It's plus this time. It's about interest. 1 plus R raised to T. Let us replace P with 2,000. Or 2K, it's the initial amount that Mr. Wong invested, times 1 plus the given rate is 8%, so that's 0.08. Then raised to t, it's missing because the question here is how many years. What about A? A here is how many years will it take for the money to double? So to double, meaning to say 2K should be doubled after how many years? So we have to write here 4K. So the missing again is time. Therefore, we can apply again logarithm here. Let's simplify. Divide both sides by 2K or 2,000. Then 2K here will be cancelled. 4K divided by 2K is 2. Or 4,000 divided by 2,000 is 2. And then, let's continue. 1 plus 0.08 is 1.08 raised to t. So this is now exponential form. Then we can already change it to logarithmic form. So this is logarithm of 2 to base 1.08 equals t. Using your calculator, this will give us Logarithm of 2 to base 1.08 is equal to 9.006 and so on. Then let's round this off. Time is estimatedly or approximately 9 years. So after 9 years, 2000 will be doubled. Now let us apply ln from here again. ln2, this one, copy. ln2 is equal to time, you copy time, and then ln, copy 1.08. Since our goal is to isolate t, divide both sides by ln 1.08. Divide ln2 also by ln 1.08. Then cancel 1.08, ln 1.08. T is equal to, this time use your calculator. Press ln2, then divide by ln 1.08. And you will also get the same thing here, 9.006, which is estimatedly 9 years also. So this is our answer. Let's have problem number 3. If Mr. Wong invested 20,000 in a bank at an interest rate of 20% compounded semi-annually, take note of semi-annually. How many years will it take for the money to double, assuming that there will be no withdrawals or deposits to be made? So the same as number 2, but this time, the only difference is the same format, but I just changed the numbers. This time it's 20,000, 20%. Now semi-annually is important here. And then it's the same that we are expecting how many years will it take for the money to double. Using the same formula, A is equal to P times 1 plus, because it's interest again, 1 plus R raised to P. Let's replace P this time is 20,000 times 1 plus R, 1 plus, our rate is 20%, which is 0.2 raised to T. And our A here is to double again. So this 20,000, when you double, will become 40,000. Now, there is another thing that you have to remember. Be careful with this. It's semi-annually here. A while ago in number 2 problem, it was annually. But this time, it's semi-annually, meaning to say twice a year. When you see like this, you go to your rate, look at your rate, and divide it by semi-annually, which means you divide by 2, and you also put 2 beside the time. So this is now 1 plus 0.2 over 2 raised to 2 times time. Now, take note, if the semi-annually is quarterly, this will become 4. Your 2 here will become 4. So again, if it is annually, do not divide R because it's like dividing by 1. So once a year. If it is semi-annually, you have to divide by 2. And if it is quarterly, you have to divide by 4. Don't forget that. Now, let's continue this. 40,000 is equal to 20,000. And then let's simplify this. 1 plus 0.2. So you divide first 0.2. So 0.2 divided by 2 is 0.1 plus 1. This will become 1.1 and then raised to 2t. Next, divide both sides by 20,000. So divide by 20,000, cancel 20,000 here. Then 40 divided by 20,000, I think is 2 again. 2. And then no more 20,000 here. Copy 1.1 raised to 2t. So this is now the exponential form. Let's change it to logarithmic form. This will become logarithm of 2 to base 1.1 is equal to 2t. So 2t is our exponent. Using calculator, you will get, so logarithm of 1.1 or logarithm of 2 to base 1.1 will become what? Then divide by 2. So t is equal to, using calculator, again, logarithm of 2 to base 1.1. Press it in your calculator. Since you have 2 here, divide the result here by 2 and you will get 3.636 and so on and so forth. And then estimatedly, let's round this off. This is 4 for 4 years. After 4 years, the money will be doubled. Now, let us use ln. From here, this is the same as ln 2 is equal to 2t is our exponent. So, bring it down 2t and then ln, copy 1.1. Using calculator, divide both sides by, our goal is to isolate t here. It's 2, then ln 1.1. So divide both sides by 2 ln 1.1. So divide ln 2 by 2 ln 1.1. Cancel this, cancel 2. Then t is, press 2, then press ln 2 and then divide by 2 ln 1.1 and the result is the same as 3.636 and more. Then estimatedly this is for 4 years. So the same answer. The 3 problems that I presented earlier were only some of the examples of logarithm. There will be more problems where we can apply logarithms, but this time, those are the only problems applicable to your level as grade 11. As you go higher, especially if you will be taking a course related to mathematics, you will encounter more problems about logarithm which are related to real life. The next slides will show you the other applications of logarithms. Here, logarithm is used to measure the loudness or softness of sound using decibel measures. Here, logarithm is used to measure the brightness of stars. This time, logarithm is used to measure pH balance. And finally, logarithm here is used to measure the magnitude and intensity of an earthquake. That's all about my presentation about the application of logarithm. Thank you and study well.